Okay, so is my screen visible? Okay, so good afternoon, everyone. My name is Mahendra Singh, and I am doing PhD under Professor Govind Swami Bala and Professor Aswin in the COS department. So today I will discuss about the monsoon low pressure systems and their influence on South Asian disasters. So the first, what is a low pressure system or a low pressure area? So a low pressure area is a region where the atmospheric pressure is lower than its the surrounding, and these low pressure systems or this low pressure area is around 1,000 to 2,000 kilometer in the spatial dimension, and in that low pressure system, wind mostly converges at the low level and took moisture along with it. And so, in the low pressure system, wind circle anti-clockwise around the low in the northern hemisphere and clockwise in the southern hemisphere. So, mostly at the low pressure area. These low pressure system mostly causes the cloudiness, thunderstorms, heavy rainfall, and mostly cyclonic winds. So, according to IMD, they have classified these LPS systems with different categories. As shown here, the first one is low, called the lows, and they are categorized with their surface wind speed. So, these are categorized like lows, depression, deep depression, cyclonic storms, severe cyclonic storms, very severe cyclonic storms, and super cyclonic storms. So during the monsoon, mostly lows, depression, and deep depressions found in the in Indian monsoon region. So currently, in the IMD shows that there is a low pressure system over Indian subcontinent. Here we can see that there is a cyclonic motion of wind, and they have forecasted 6 hourly. So the first figure shows they have forecasted on 00 UTC 27th of June, and this forecast is for 6 UTC 27th of June. So here we can see that there is a low pressure area formed, and similarly for the another after 6 hours it is evolving, and mostly low pressure systems moves in the northwest direction. So here we can see that after the 6 hour and for another 6 hours around 18 UTC time, and there you can see clearly a low pressure system, and also for 00 UTC 28th of June. So for our group, Trissa ma'am done most of the work on the LPS. The first of their work was basically mainly based on the tracking algorithm and its implication on real analysis product, and the second and third part mostly explain the orographic effect on the low pressure systems. And the fourth one is the model study of warming climate, how LPS characteristic has changed in the warming climate. So today I will discuss this particular paper, which is mostly focused on the influence of monsoon low pressure system on southeastern disaster. This is recently published, and Professor Srinivasan sir suggested someone could present this paper. So I thought I can present that paper. So so what are the methodology and data they have used? So for the disaster information, they have used emergency event database, and they have selected the South Asia region for their study, mainly focusing on Pakistan, Bangladesh, Bhutan, Nepal, and Sri Lanka, mostly, and India. So they have included only two type of disaster, mostly which is mostly connected to the low pressure system. We can say that hydrological and meteorological disaster. They only consider these two type of disasters. So they have introduced a term a disaster count, disaster event. They have introduced this term as the number of for a disaster event, the number of all disaster locations uh, uh, at a particular time, and averaging that, like on that time, averaging for all the locations of that disaster, they called it as a disaster event. So for LPS tracking, they have used the ERA 5 data, and they classify a disaster event as associated with an LPS if the at least 50% of its location, uh, which they have considered at within the 800-kilometer radius, are individually associated with the LPS. So for rainfall, they have used a global precipitation measurement mission, some product which is 0.1 degree into 0.1 degree resolution. So here the table one and table one shows the summary of disaster information data set. So they have included time from 1990 to 2019 and only monsoon season, JJS season. So they have counted total number of disaster around 344 disaster events, and to 2394 disaster locations. So they have only included the hydrological and meteorological disasters. So here we can, from that table one, we can see that around more than 90% of the disaster events are of hydrological or meteorological origins. And here in the from the table 2, we can see that uh, around half of the disaster events are mostly tied up with the LPS. Here we can see that around 180 disaster events are associated with the LPS. So although monsoon lows occurs more frequently than depression, the depressions are more reasonable for disaster. Uh, here you can see that the depressions are associated, around number of depressions that are associated with the disaster is around 129, and for lows it is 103. However, lows are more as compared to depression. So there are also some overlapping between the lows and depression, because one or two disaster, one disaster may be associated with both low or depression sometimes. So that is why number of is more. So first here figure shows the spatial distribution of disaster. So the figure first shows the location of hydro and meteorological disasters, which is shown in the red circles, red dots we can say, and that brown line are the LPS tracks for 1990 to 2019, and blue lines mostly showing major rivers. So here in figure A, we can see that most of the disaster events are near the foothill of Himalayas, and some of them are in the like we can say that the central India. And the second figure shows the location of a disaster relative to the LPS center. So here we can see that here if we can see that for a LPS, if the center is on 0 degree north or 0 degree south, relative to that point, we can say that most of the disaster locations are mainly north of that system, most north of the LPS system. So they have explained this could be there could be several reasons, but major reason could be the two kind of thing. The first one is the large human population, and the second one is geomorphic factors. So for that, they have also shows the population distribution of of the population density, we can say that. So here in figure, they have shown the spatial distribution of the population density, and the second figure shows the relative like storm center composite of population density. So here we can see that the that population is mostly lies in the north or northwest direction, and under the foothill of Himalayas. So this is coinciding with the disaster. So here these figures shows the A figure shows the disaster count, that is number of disaster locations associated with the monsoon LPS, and the second figure shows the fraction of days in monsoon season which are under the influence of low pressure systems, and the C figure shows that the relative risk of disaster due to the presence of the LPS. So relative risk defined as the ratio of probability of occurrence of disaster during LPS event to the probability of disaster in the absence of LPS. So clearly we can see that here from the disaster count, mostly the near the foothill of Himalayas disaster count is higher, and as we see that the LPS days is mostly in the east or central India, of the central India, where most of the monsoon LPS forms or lives. And if the coming to the relative risk, if the relative risk is higher than 1, then that shows that disaster relative to the LPS is high. Like if LPS is present, then risk of a disaster is high. So sorry. So here they have shown the fraction of disaster location associated with all low pressure systems, and figure B shows the for only for depressions, and figure C shows only for lows during the monsoon season. So here we can see that the over a large part of domain, more than half of the disaster locations are associated with the monsoon low pressure systems. Even though we in the previous figure we can see that the other where LPS days are less than 50%. However, we also on that locations we also found that LPS related disaster is higher, or more than 50% in the monsoon season, and the contribution of monsoon depression is above 50% over most of the region. As from figure B we can see that mostly central part of India, we are seeing that most of the part is have above the 50% effect, while the disaster associated with the lows are mostly concentrated over the Nepal, Bhutan, and northeastern India, as well as like along the Ganga and Brahmaputra river basin. Here we can see that they have explained this could be because the monsoon depression mostly forms and travel in the central part of the India, and monsoon lows mostly goes further north, or we can say that near the foothill of Himalaya. So that here figure this figure shows that the difference between the track density between the depressions and lows. So here we can see that if in the central region the difference is high, that positive. This shows that in that region depressions are more as compared to lows. So and near the foothill of Himalaya and lows, the difference is negated. That shows that low that region forms more often for lows. Now here they have also connected the monsoon precipitation with the disaster events. So here they have plotted the composite mean of time series of observed daily rainfall at the disaster location for the disaster events. The first one is for LPS days, and the second figure B figure is for non LPS days. So So here we can see that during the day of disaster, LPS during the day of disaster rainfall peaks around, that peak is around 30 per day for LPS days. However, during LPS, these peak is mostly higher, as like around 60, sometimes 60 per day. But as we know that during the LPS, the rainfall peaks mostly falls in the southwest region of the LPS, but disaster mostly occurs in the northern part of the LPS, as we see before. So so that is why that peak is reduced in the in the composite mean, because the composite mean is calculating only nearby the disaster location. So like only the 1 degree circle of that disaster location. So that is why that peak is around 30 per day. So here we can see that we can see that the most of the rainfall is mostly the day of the disaster. So also we can see that at day zero, rainfall is around 50% higher when disaster is associated with the non with the LPS as compared to non LPS disaster. So so here is the summary, that the disasters are mostly heavily concentrated along the Himalayas and upper basin of the Ganga and Brahmaputra river, and more than half of the disasters are associated with monsoon low pressure systems, and the disasters associated with monsoon depressions are more frequent and geographically widespread with strong precipitation and compared to the disaster associated with the monsoon lows. And so that relative risk of a disaster occurring when the LPS is present within 800 kilometer of a location is larger than one in most of the domain, with relative risk exceeding around 10 in most some regions. And mostly human exposure may contribute the spatial offset between the peak of rainfall and the disaster location. As we saw that rainfall peak mostly happens in the southwest region of LPS, and disaster happens in the northern part of the LPS. And the peak rainfall is more prominent for disaster associated with monsoon low pressure system than the non monsoon like non LPS disaster. So this suggests there is a physical link between the LPS and hydrometeorological disasters. Thank you.
Question. What is the
Yes, sir.
basis of that 800-kilometer distance they have chosen?
Actually, they have said that most of the previous studies mostly use that radius, but they have also checked for 500 kilometer to 1000 kilometer radius, but they did not find that much of changes in the like results. So they have choose the 1800 kilometer radius.
Okay, thank you.
Thank you, sir.
Right? Okay.